You are studying the motion of a simple harmonic oscillator that cycles every t equals 4 seconds. By the way, if you don't know what a harmonic oscillator is, just imagine a string, and on the bottom of the string there's like a weight or something like that, and it bounces up and down and up and down, so you can see that it's sinusoidal. Okay, you have collected a table of values representing the height h inches of the oscillator above a reference point. Write an equation in the form h of t equals a sine b times t plus c, all in parentheses, plus d. This is a calculator problem. So we're going to use sinusoidal regression in our calculator to help us figure this out. So let's go off to the side and see what happens when we do that. All right, time to get our SinReg on, which last time I checked, according to the Bible, we shouldn't sin ever. Hit stat, go to edit, and let's plug these points in. So while I plug these points in, now would be a very good time for you to run to the comments section and say, wow, that SinReg joke was absolutely hilarious. By the way, this is 11.7. If your eyes are bad, I apologize. And these are points, so 7.2. And by the way, you should be noticing that now these numbers are repeating, and that's because it's sinusoidal. It goes up and down and up and down and up and down. So make sure you don't make any typos, like I almost did just there. And keep working your way up and down until we get there. And then 11.7, and then 7.2. All right, so A is asking us to find the equation using sinusoidal regression, and then the other problems are going to ask us to use that equation to do something else. So I go to stat, I go to calc, and SinReg is somewhere down here, SinReg, there you is. And not only am I going to use this formula, but I'm going to store this regression equation so I can use it for later. All right, so let's go down to store. By the way, you never need any of this. I've never found a reason to use any of that, so I'm not sure what the point is. I'm not going to worry about it. Go down to store reg eq so we can save this into the y equals button. Hit vars, go to y vars, hit enter, and there it is. So when we hit calculate, yeah, it'll give us something, but now we can also use this for later. Okay, so we have 4.5, 1.571, 1.571, and 7.2. So let's go off to the side and write that out. All right, so we ended up with h of t equals 4.5 sine, parentheses, 1.571 t plus 1.571, close the parentheses, and then plus 7.2. Predict the height at time t equals 17.5 seconds. So that's just a simple matter of us using the equation that we stored in the calculator and finding out what happens when we plug in 17.5. Let's see what happens. All right, so B is asking us to predict the height at time t equals 17.5 seconds. So if I were to go to my graph, I'm not going to get 17.5. My bad. If I were to go to my graph or my table, I'm not going to get 17.5. Also, if I were to hit graph, I still won't see 17.5. So if I try to do the whole value thing, it won't let me because 17.5 is not on the screen. Watch it yell at me. So what I need to do is I need to extend my graph so that I can find the value at 17.5. Now looking at C, we're going to need also to use the point 22.2. So I'm going to go to my window. I guess I have to quit this first. I'm going to go to my window, and I'm going to keep everything the way it is, but I'm going to change my X max to 30. Okay? X max is now going to be changed to 30. So when I go to my graph, or I'll hit graph first, there it is. Now when I go to calc and do value, I will be able to type in 17.5. So it's just one of the flaws that the TI-84 Plus calculators have. But by doing this, we get 4.018. So let's go off and write that out. We ended up with 4.018 inches. All right, find the average rate of change for the first 22.2 seconds. So the average rate of change formula is going to look like this. So what I need to do is I need to run to my calculator, find out what happens at 22.2, then minus, I already know what happens at 0. It's the first 22.2 seconds, so that's going to be 0. So I'm going to take whatever that number is, minus 11.7 over 22.2 minus 0. So let's see what happens when we do all of that. All right, so let's use that formula. We have the average rate of change. Now, we don't know what the average rate of change is yet until we find out what happens at 22.2 seconds. We do know we're going from 0 to 22.2. So the nice thing about this is since we have 0 there, all I have to do is look at my table to find out what happens at 0, and that's 11.7. Okay, now at 22.2, we can do the same thing we did for part B and type out value and do 22.2. And that's going to get us 2.92. 2.920, but we're going to stop at 2.92. So to set this up, all right, we're using the formula f of b minus f of a over b minus a. So this is going to be f of b. 2.92. So let's quit out of this and do 2.92. Now, if you remember, the table started you out at 0 with 11.7. So we're going to do 11.7 as our f of 0. Now we divide that by 22.2 and then waste our time a little bit and say minus 0. This is all we need. This is the average rate of change formula. Hit enter, and you get negative 0.395. Okay, so let's go back and write that out. All right, so what we did is we did 2.92 minus 11.7 all over 22.2 minus 0, which ended up being negative 0.395 inches per second. Okay? So that's free response question numero dos, baby.